So we're going to do electrical dead testing, and we're going to start with our first test, which is continuity of protective conductors. So first of all, I'm going to test my main earth. Now in this one, I know that this is just a training rig, so there is no safe isolation. I am confident this is dead. In your assessment, you will be making sure that you isolate at an appropriate point. In this case, it will be at the main switch. Because there is no supply, we don't have an incoming earth, but we do have a earthing conductor there, and what I'm going to do now is disconnect that to avoid any parallel paths with the bonding. So I will disconnect that. So depending on your setup will depend on what you disconnect. In this case, I've disconnected the main earth. You can disconnect the bonding, whichever is more suitable. Okay, so the tester we're going to use is the QTech KT66, similar to the one that you're using in your assessment, and I'm going to have that set on continuity. And what I will do is I will set this to null. So to do that, all I'm going to do is press and hold the test button, put my two leads together. Now I've already nulled this, but what you will do is literally just press null until you get a 0 reading. Okay, so with this, what I'm after is a nice low reading. I expect this to be almost 0 because it's less than a metre of cable. So I'm going to put one terminal up there, one terminal on the other end of that, and I've got 0.04. So nice low reading. That shows that it's continuous. I'm happy with that. So the next test, again, making sure that it is disconnected. I'm going to test from my main earth, and I'm going to test the bonding this time. So again, I want a nice low reading. What I'm going to do now is I'm going to test the actual pipe work. So that's 0.04, and if you can see down at the bottom, I've tested on the pipe work. The reason we do that is to make sure that the actual pipe is connected to earth and not just the earth label. Test the other, and that is 0.08. So again, nice and low. This is a training rig, so your results may be different depending on your installation. So I'm going to reconnect my main earth now. So remembering our CRIPA acronym, we're still on continuity. I've done continuity of protective conductors and earthing conductors. Now what I'm going to do is continuity of circuit protective conductors. So first of all, for no reason really, I'm going to start with the lighting. And what I'm going to do is create a temporary link between the line and the CPC. So there are many ways of creating a temporary link. The way I'm going to do with this, because I've got enough length on that line conductor, I'm going to put that into my earth bar, and this can go anywhere because it is all one bar. So now what I've got there is a temporary link made between line and CPC on the lighting circuit. For the next test, again I'm going to leave it on continuity, and instead of my crocodile leads now, I'm going to change these over to the probes. Now I've got multiple lights on this circuit, so I've got one there, and one there. I've got a switch, and I've got a two-way system. So in this particular system, that switch controls that light. These two ways control that light with that one fed off it. Now what we need to do is test all lighting points, so that would include the switches as well. So I'm going to put that in there. So this is still an auto test, so all I need to do is put my probes on. So I'm going to connect onto the switching line of the pendant, onto the earth, and we've got a reading once I've settled of 0.73. Now to test polarity, I've pressed on a little harder there and the result's gone down. Make sure you get a good connection. So I've got 0.50. I'm going to turn the switch off, and what we expect now is this to go off the scale, which it has. So that's shown that the switching line goes through the switch. Turn it back on, and the results pop down again. Again, I've got slightly different reading on there, probably because the switch had a little bit of dust in it, so if we operate that, there you can see it's dropped down. I'm going to do the other switches now, so I'm going to again go onto the switching line, onto the earth. So this is switched by this two-way, so in the minute that is in the on position, so we've got 0.58, I'm going to operate that switch, that is open, I will operate the other two-way, 1.02, switch that off, I'm going to close that again. So, because these have got a little bit of dirt inside them, if we switch them off a couple of times, we get very different readings. So I've got 0.34 on that switch, 0.31 on that switch, and we would record the highest. Okay. I've got another light here, which I'm going to test, which is on the same circuit. So again, on the switching line, onto the earth, and we've got 0.29, which is lower than that light, which you would expect because that light is fed off this one, so there's less resistance. But I will still operate the two-way, open and closed, 0.34. So again, we would record the highest results. So what I've done now is open one of the switches just to show you how you test inside the switch. This switch is still in the on position, or the closed position, controlling that light switch. So I don't need to test that, I need to operate the switch. What I will do is put my probe on the CPC and on any of the lines, and you can see there we get a nice low reading, settle down on approximately 0.46. You would do that at every switch in your circuit and every lighting point. So every point on your lighting circuit needs to be tested. If this was a radial circuit or you wanted to absolutely confirm polarity, what you can then do is take out that temporary link, and we will put that back into the device. Now, because my neutral is a little bit awkward to get at, I'm going to use my little fly leads. Now, just to make sure we don't get any unusual readings, I'm going to null these out, and that's zeroed our leads. So I know any reading I get now will not include these leads. I will attach that to the neutral bar, and again, anywhere on the earth bar, because that is all nulled. I will then go to my lighting points, sorry, my neutral and my CPC, and I've got 0, just to make sure I have definitely got polarity and the neutral isn't being switched. I've operated the switch and we get no change. I'm going to do that at all the lights and expect a very low reading, in that case 0, and 0 again, in which I will operate the switch, and we've got 0 ohms, which means it is a complete circuit, therefore polarity is proved. I will remove that. Next up is the testing of the ring final circuit. Okay, so for our ring final circuit, what we'll do is disconnect all the ring final conductors. This is again still within the continuity, but this time we are doing ring. So in Cripper we are up to R. Disconnect CPCs. So the first step we need to do is a end-to-end test. This will prove that we have actually got a ring circuit. So if I put that on my line and that on there, we've got 0.02, steadying out at 0.01. Again, that is a very low reading because it goes from there through these 4 sockets and back. In your installation, you will get very different results. In fact, in most houses, it is quite common to see anywhere between 0.5 ohms and 1 ohm. Now, because the neutral conductor is the same size and type of the line conductor, we shall be getting the same reading. So we expect 0.02 or thereabouts, 0.02. So that's ideal. For the CPC, in this particular conductor we're using 2.5, 1.5 flat twin and earth. The CPC is much smaller, therefore we'll have a greater resistance, and so we expect that to be about 1.67 times higher. And what we've got here is, if we calculate that, so if we do 0.02 multiplied by 1.67, we expect a reading of about 0.0334 ohms. Now, these testers normally only work up to 2 decimal places, so we will be looking at around about 0.03. Okay, and you can see there that our reading is 0.04, which is round about what we expected. Okay, so now we have established that there is a ring main on the line conductor, the neutral conductor, and the CPC. What we're going to set up now is our figure of 8 to prove polarity. So to test figure of 8, what we will do is take one leg of our line conductor and we will connect it up with opposite leg of the neutral conductor. Now, this is a good idea for when you're doing consumer units, to put a mark on your circuits. So you can see on there I've got 2 marks on there, no marks on that, 2 marks on the line, 0 marks on the neutral. So I've pre-marked these up and I will now connect these up. Okay, so the lead we're using now is our plug-in lead. Because we're testing line and neutral is what I've put in there. Now, in this particular tester for doing continuity, you put one in L1 and one in L2. Different testers will have different setups. Make sure you read the instructions. So because our line conductors and our neutral conductors were 0.02 ohms each, I'm going to do 0.02 plus 0.02. On this calculator I have to do brackets, divide the whole lot by 4, and we are expecting a reading of about 0.01. Again, in your larger installations you will get a very different reading. So all I'm going to do at every socket is plug that into there. Now if you get a high reading, it may just be that there's a little bit of dust and dirt going on within the socket. Okay, so after a quick bit of contact cleaner, I'm going to plug that into my sockets now. So we've got 0 on that, 0 on that socket, 0.15 on there. If we switch a few times, we've got 0.02, a little higher than we expected. And 0.02 again. Now that could just be simply due to the socket, but that is round about our expected 0.01 ohms. So all we've done there is we have proved R1, R2 for live and neutral. Now in our socket, live and neutral are there. In this particular test, it doesn't tell us which way around they are. If line and neutral was the wrong way around, we would still get that same reading. So what we need to do now is set up an R1, R2 with the CPCs and the line, and that will also give us our R1, R2 reading. And for this test, again, I've done opposite legs, so we've got marked up line, unmarked CPC, unmarked line, and marked CPC. So the last result we got on our test was 0.02 for our line conductor, 0.04 for our CPC. So again, using a quick calculation, 0.02 plus 0.04, all that over 4, gives us an expected reading of about 0.015. There or thereabouts, so it's not a million miles away from what we had earlier. So because we are now testing line and earth, I have taken my neutral pin out of the tester, replaced it with the CPC, and that is going to test now between line and CPC. So we are now expecting round about 0.015, okay, hovering between 0.1 and 0.2, so that is exactly where we wanted it to be. I'm going to test that tester socket. That is on 0, which is a little bit low, but oh, there we go. So because we are dealing with very, very small readings, it can be slightly off. Again, in your installation, you may be dealing with much higher readings. The process is exactly the same. These readings are small because this rig is small. 0 again on that one, and on that particular socket, we've got 0. Now, I'm going to record the highest on that, which was 0.01, and that is what we will put on our test sheet. Again, your installation will look different. Okay, that's the ring tested. So we've proved live and neutral are at each socket, and then we have proved that line and earth are at each socket. Because line has been there both times, polarity is correct on all points. If polarity was wrong on one of the sockets, we would not get a reading. Okay, for our next test, we are doing insulation resistance. Now you'll notice I've put everything back together because we are now going to be firing voltage through the circuit, and we want all the fronts back. So if you have taken any fronts off, we need to make sure they are on. These lights don't have any covers. Now, because this is a training rig, I've got full control over them. So in my risk assessment, I'm happy for those to be open because there is only me working here. If you are working on a full installation where there might be other people, or these are in different locations out of eyesight, then you will need to make sure they are covered. So for the next test, we are doing insulation resistance. I will set my tester to insulation. Now we have a reading there that will tell us the voltage, which will cycle between 100 volts, 250, 500 and 1000 volts. This being a mains 230 volt circuit, we need to make sure that we are testing at 500 as it states in the on-site guide, and we are looking for a reading of a minimum of 1 mega ohm. Obviously the higher the better. If this was under 20 mega ohms, we would be looking for any issues. Now in this particular test with lighting circuits, we have left them all in the on position. I have made sure that there is no voltage sensitive equipment such as inline RCDs, luminaires, any motor controls such as contactors, as they may be affected by the voltage. If you have any of those, you need to disconnect them. So in this particular test, all I'm going to do is test between the line, the CPC and the neutral conductor of every circuit. So for the lighting, I will put my line on line. I'm going to test on CPC. I'm going to press this tester and I'm hopefully going to get a reading that is off the scale. So we've got a reading there of greater than 1049 mega ohms. That is much higher than our minimum permissible 1 mega ohm. Effectively, line and CPC are not touching. The next test I will do is line and neutral. And again, we've gone off the scale there of 1049 or greater than. So the last one will be neutral and CPC, and again that is off the scale. So in this particular circuit, line, neutral and CPC are completely separate from each other. Exactly the same process for the sockets, and we do all our testing here. You'll notice as well that all the MCBs and devices are in the off position. That's because if they were in the on position, voltage would be able to flow through there and into the RCD, which could potentially damage that. So we'll make sure everything is switched off. So again, I'm going to go line and CPC. It doesn't matter which way your probes are, it is the same test. Again, 1049, I will do line and CPC, so with line and neutral. And now neutral and CPC, which we did for the light, but I'm going to repeat it. And we've got 1049. One minor point about the lighting is if you've got a two-way, you need to operate it in both positions to make sure both strappers are being tested. So next up would be our live testing. Since we have done a continuity of protective conductors, continuity of CPCs, we've done our ring, we've done our insulation resistance. In doing the test that we have done, we've also proved polarity in the dead tests. Our next test would be polarity live, earth fault loop impedance, fault current, ZS, RCDs and functional